Hello everyone. In this class, I will discuss few application of Thevenin's theorem. In the previous class, I have discussed the Thevenin's theorem and experimentally and analytically. But in this class, I will discuss few application. Let's see the circuit diagram. This is the circuit diagram, and in that circuit diagram, I will calculate the current through 5 kilo ohm resistance. Okay. So I have to apply a Thevenin's theorem at the point A and B, and Thevenin's equivalent circuit will be Vt and Rt, and this is 5 kilo ohm. This is A terminal. Okay, this is the Thevenin's equivalent circuit, and I have to calculate current through 5 kilo ohm. So from this circuit, first I will calculate Thevenin's voltage. Okay. For the calculation of the Thevenin's voltage, actually in the circuit there are two energy sources. This is voltage source and this is current source. So for both the source, we have to calculate the voltage across the terminal A and B. So let's start. For the calculation of the Thevenin's voltage, first for 18 volt, what will be the voltage across B for 18 voltage source? This circuit can be written as just like that. This is the terminal A and B. This is 2 kilo ohm and this is kilo ohm. This is 18 voltage. This is the circuit, because I will calculate the voltage across the terminal A and B for 18 volt, and this is the current source. So we know, actually we have to consider the current source is ideal current source, and for ideal current source, ideal current source, internal resistance is infinity. Okay. So this is the equivalent circuit. So what will be the voltage across the AB terminal? Actually the circuit is open, so no current flowing through the loop. So the voltage across AB, VAB equal to 18 volt. Okay. So this is the voltage across AB due to the 18 volt, and for this voltage source, upper side become positive and lower side become negative. This is a number. And for the current source, what will be the voltage at the terminal AB? For current source, we have to replace the voltage source by the internal resistance of the source. And for ideal voltage source, internal resistance is 0. So the equivalent circuit for the determination of the resistance, determination of the voltage across A and B. What will be the voltage across A and B? This is 2 kilo ohm and this is 3 kilo ohm. 2 kilo ohm or 2 kilo ohm and 3 kilo ohm remain in series. Okay, so the voltage drop across 2 plus 3 kilo ohm is the, so this circuit can be written as, can be drawn as, this is 2 kilo ohm and this is 3 kilo ohm, 2 kilo ohm, 3 kilo ohm, and this is A, B, and this is the 6 milliampere. So what will be the voltage across the AB terminals? VAB, let this is VAB1 due to the voltage source and this is VAB2. This is equal to 2 kilo ohm plus 3 kilo ohm, they are in series, so the total resistance is 5 into 5 kilo ohm into 6 milliampere. Kilo ohm into milliampere means voltage, so this is 6,530 volt. Okay, and since the current flowing from this way, so upper side become positive, lower side is become negative. So 18 voltage source produce 18 volt. Upper side become positive, lower side become negative, and also the 16 milliampere current source produce 30 volt. Also upper side become positive and negative, lower side become negative. So the total voltage appear across A and B due to both the voltage source and current source will be Vt. That means the voltage across AB, Vt is equal to 18 plus 30 and this is equal to 48 volt. Okay, so this is the Thevenin voltage. Okay, now I will calculate the Thevenin's resistance. For calculation of the Thevenin's resistance, we have to replace the energy source by their internal resistances. Okay, so the circuit will be 2, this is short 3 kilo ohm, this is the terminal A and B, and this is the current source, have infinite resistance, so this is open. So what will be the equivalent resistance between the A and B? This is 2 kilo ohm and this is 3 kilo ohm and this is RT, and RT equal to 2 plus 3, this is 5. Very simple. So this is the Thevenin's resistance and this is the Thevenin's voltage. So the current flowing through 5 kilo ohm resistance will be IL equal to Vt by total resistance in the circuit, RT plus RL. RT is equal to 48 and RT equal to 5 and RL is equal to 5, so 4.8. This is voltage and this is kiloampere, so 4.8 milliampere. So this is the current flowing through 5 kilo resistance. Okay, thank you.